Next, we are going to talk about OSPF summarization and filtering. And here we are going to explore the summarization, the IP summarization of inter-area routes, the summarization of external redistributed routes, and here we are going to take a look at both type 5 and type 7 routes. And then we are going to take a look at some filtering capabilities of OSPF, especially when it comes to the inter-area routes, and we are going to take a look at a special feature of OSPF, which is the local route filtering. This is the feature when we are going to be filtering the routes between the database and the routing table. In OSPF, unlike some other routing protocols, IP summarization has to be configured manually. So OSPF in iOS implementation does not support any automatic summarization at the network boundaries, which is a good thing, because that feature of auto summarization supported, for example, by RIP and EIGRP is a feature that is best avoided. However, unlike those other protocols where we can perform summarization wherever we like, in OSPF we cannot do that. We cannot do that because of the flooding scope of the LSAs that carry routing information in LSAs, in OSPF. So where we can perform IP summarization is at the area boundaries and also at the autonomous system boundaries on ASBRs. So at the area boundaries on the ABRs, we can perform the summarization of internal routing information, or I should be more precise and say inter-area routes. Now you might remember when we have a router that acts as an ABR, that router is connected to area 0 and one or more other areas. So let's say that here inside our area 1 we had routes that were coming in as type 1 and type 2 LSAs. If we had this situation here, these routes as they are arriving as type 1 and type 2 LSAs, when they're being advertised into the area 0, they're going to be summarized. This LSA information will be summarized into type 3 LSA. At this point, at the injection point of this type 3 LSA is where we can not only leave the summarization at the LSA level, but we can also perform IP summarization. What I mean by this is if we had, for example, route 192.168.0.0/24 arriving and route 192.168.10/24 arriving. Now this would be this would be arriving as a set of its own type 1 and type 2 LSAs, and this would be arriving as a set of type 1 and type 2 LSAs. Now, what is going to be generated here at the ABR will be two type 3 LSAs, one for this network and the other for this network. What we are summarizing is the information in the LSAs here, but we are not necessarily performing an IP summarization. But we can do the IP summarization as well, but this needs to be manually configured. So we could advertise these two networks here as a single network. We could advertise it here as 192.168.0.0/23, for example, with this single with this single prefix, with this single summary here, we are still going to provide reachability to both of these networks. So we can perform not only the summarization of the topology information, but we can provide the summarization of the routing information as well. And here is an example of that summarization. So here is the syntax. We would go into the router OSPF and we would say area 10 range, and then we would specify what is the summary that we want to advertise. Now, I should point out that this particular syntax here needs to be configured, obviously, on the ABR that sits between areas 10 and area 0. So on this boundary here, all networks from this range will be injected into the area 0 as 192.168.0.0/16. Keep in mind that this does not affect networks that might be advertised from area 0 into area 10, or let's say from some other area. Let's say that this here is area 11. networks arriving from area 11 into area 0 will not be affected by this summarization. This is summarizing only the networks as they are arriving from area 0 and then going into, from area 10 and then going into area 0. Now, as you might remember, external routes in OSPF don't really belong to any particular area, with one exception, with the exception of the NSSA externals, but they behave in context of summarization, they behave the exact same way as normal externalized type 5 LSAs are behaving. And given that the flooding scope of type 5 LSA is the entire domain, this means that this summarization, the summarization of the external routes, and the syntax there is summary address and then simply a summary. Please note the lack of any area identifiers here. This can be only done on the ASBRs. So for external routes, we can perform the summarization only at the ASBRs. Special case here are obviously type 7 LSAs. Why would they be special case? Well, imagine that we had our, let's say, maybe I need a different example. I just used 3 routers here. So let's say that this router here, R1, this here was ASBR in the NSSA area. And let's say that this router here was redistributing some number of external prefixes. We can configure summarization on this ASBR and we can summarize these prefixes in here. Now let's say that our R2 here is actually an ABR between area, let's call it 12, and area 0 here. Now let's say that these prefixes here were summarized as /16 and R2 might have another area here. Let's say that this is router R3, and let's say that this is area 23, also NSSA, and that this router 3 is also advertising some routes. So when we advertise from R2 to, for example, our R4 here, we may want to advertise these prefixes, these external prefixes, as, let's say, /8. This is doable on R2 because R2, you might remember, when it translates from type 7 LSAs arriving from these NSSA areas, when it generates this type 5 LSA, it is also going to be claiming technically that it is an ASBR, which means that we can perform summarization on the router that appears to be an NSSA ABR, but NSSA ABR is at the same time functionally NSSA ASBR. Now, you might remember, if you have watched the EIGRP summarization video, that I have spent considerable time there talking about the concept of the discard route. I'm not going to repeat that discussion here, so if you are unfamiliar with the concept of the discard route, I suggest you go back and watch that particular video and then come back and watch the continuation here. So I'm going to give you 3-4 seconds to do that. 1, 2, 3. Perfect. Now that you are back, discard route in OSPF is installed by default. That means that when you create the summary, either of the internal or the external routes, you are going to get the discard route. The discard route will be pointing to null 0 interface. It will be always installed as an internal OSPF route, regardless of what you are actually summarizing. Are you summarizing external routes or are you summarizing inter-area routes? What you are going to end up having as the discard route in the local routing table of the ABR or the ASBR performing the summarization is always going to be an internal route. However, depending on what you are summarizing, this route will be installed with a different admin distance. Don't shoot the messenger. I have no idea why iOS does it this way, but for the internal summaries, for this syntax here, what we are going to end up having is going to be the admin distance of 110 for the discard route. If you are performing the external summarization, what is going to end up being installed as the admin distance for the discard route will be 254. In both cases, the discard route, if you need to do that, can be suppressed. The syntax for that is under the OSPF process. You would go under router OSPF, let's say 1, and you would simply say no discard route. With this, we are going to suppress both internal and external discard routes. So if I press enter here, actually I'm doing this, I'm suppressing both. But I can also specify, for example, no discard route internal, and in that case I will suppress only the discard route that will be the result of this configuration. Similarly to that, with the external keyword, I can suppress the discard routes that would be generated when I perform an external route summarization. I can use the similar syntax, discard route, for example, internal, and I can specify the admin distance that I want to use. If I don't like 110 or 254, which are the default ones, I can actually specify the admin distance that I want to use for my discard route. But enough talk about this. Let's take a look at this stuff in action. The network that I'm going to use is going to be the same network that I have used and built in the previous OSPF examples. So as a quick reminder, what I have here is backbone area, area 0, that consists of 3 routers, R1, R4, and R3, and they are interconnected on this shared segment. Even though it's not relevant here, R3 is the DR on this shared segment, and R1 and R4 are DR others. I also have between R4 and R5 point-to-point link, which is in area 45, and in this area 45 on R5, R5 is injecting 192.168.0.5 as an internal OSPF route. Between R1 and R2, I have area 12 NSSA configured here, and on R2, I have a loopback 0 interface 192.168.0.2/32, which is actually being redistributed. So here I have an external route that is being injected. Now it will be type 7, but it doesn't matter. I will show you the behavior of both type 7 and type 5s in this case. But first, let's take a look at the summarization of internal routes. One place where we can start, or the most logical place where we can start exploring this, would be on R4. So let's summarize this 192.168.0.5 loopback as it is being advertised from area 45 into area 0. So I will summarize this 192.168.0.5/32. I'm going to summarize it as, for example, 192.168, let's say 00/29, for example. So this is going to be the summary that I'm going to create when this route is being advertised into area 0. So I'm going to head over to my R5 here, and the first thing that I want to do is I want to make sure that I am actually receiving my 192.168.0.5 route here, that it's an internal route, and I'm receiving it on gigabit interface 3. So this here seems to match whatever I have on the diagram. So what I'm going to do now is I'm going to go into my router OSPF1 and I'm going to say area. So which area am I summarizing here? If I go back to the diagram here, I will see that this is area 45. I want to summarize the routes as they are going from area 45 into area 0. So this is exactly what I want to do. So what I need to do here is area 45 range and then specify the range. 192.168.0 and 0, 255, 255, 255, 248. This will give me /29 route. So now that I have done this, I'm first going to look at show IP route OSPF on R4 itself, and what I'm going to be seeing here is going to be the discard route that was created. So I can see that R4 immediately created a discard route. It says it's a summary, it has this null 0 as the exit interface, and if I take a look at show IP route 192.168.0.0 and with the net mask, I will see that this discard route was installed with the admin distance of 110, as I expected to see it. So if I go, for example, to R3, which is one of the backbone routers here, so I have R3 here, what I should be seeing if I do show IP route OSPF, I should be seeing now the route for 192.168.0.0/29, and I'm seeing it as an inter-area route. So I can see that the summary actually made it across, and the more specific route that was advertised before is now being suppressed. Now let's go to our R4 again, and I'm going to now say area 0 range, and I'm just going to say 192.168.0.0, and let's say 255.255.255.128. So now I'm going to summarize all the routes that are coming in from area 0 as they are going into area 45. So this is the summary that I'm creating now. So this is the summary that is created now. And here I'm going to say 192.168.0.0, and what did I say? /25 was the prefix length. So if I go to R5, if I do show IP route OSPF, this is what I am going to be seeing. I'm going to be seeing the inter-area routes. They're all going to be summarized as 192.168.0.0/25, but take a look at the next line in output. Here is this route, 192.168.0.2/32, which should have been covered by this summary, but it is not covered by this summary. It's not covered by this summary because this is an external route. External routes, because the flooding scope of type 5 LSAs is the entire domain, they cannot be summarized on the ABRs. They can be summarized only on ASBRs. So let's take a look at the summarization of the external routes. To do that, I'm going to head over to my R2. And because R2 is injecting this prefix that I'm having a problem with, let's summarize on R2 this prefix as it is being injected here. Let's summarize it as 192.168, let's say 0.0/30. This should cover 0, 1, 2, and 3 networks here. So I'm going to summarize this as /30 as it is being advertised into the NSSA area here. So going to my R2, I'm going to say configure terminal router OSPF1, and I'm going to say summary address 192.168.0.0, 255.255.255.252. Now if I do show IP route OSPF, what I'm going to be seeing is this route 192.168.0.0/30 as a summary pointing to null 0. This is my discard route. If I take a look at this route in some more detail, so I'm going to say show IP route 192.168.0.0, 255.255.255.252, I will see, I will see that this route is installed, but with the admin distance of 254. I did mention that for the external prefixes that are being summarized, this will be the case, but the route itself is still an intra-area route. So now I have this external prefix that is being advertised. So if I go back to R5, if I do show IP route OSPF, I will no longer see this /32 here. I'm now seeing the /30 route because the summarization has been performed. Now, keep in mind that this /30 here that we are learning, that we are observing on R5, is not the same LSA that was generated by R2, because this LSA arrived to R1 here, and R1 can perform additional summarization when it advertises the routes here. So let's summarize this as 192.168.0.0, let's say /28, just to have one more route in place here. So I'm going to go to R1, and I'm going to say here router OSPF1, and I'm going to say, so what am I going to say here? Area range or the summary address? Well, let's take a look. This here is an external prefix, so we are trying to further summarize this one that is arriving as N1 route, and N1 will be type 7 LSA. So if I do area range, it will not affect external routes. Let's give it a try. So I'm going to go to R1 and I'm going to say area range, and this is area 12 that I'm dealing with, and I'm going to say 192, 168, 00, 255, 255, 255, 240. Oops, area 12 range, slight mistake there, apologies. So now if I do show IP route OSPF, I don't have the discard route. I don't have the discard route because this summary wasn't affected. It did not affect this prefix here. This is what I wanted to summarize, but it cannot be affected because this summarizes only internal routes. So if I remove this and if I say summary address, and basically pretty much the same thing here, now if I do show IP route OSPF, now what I am going to be seeing, oh, okay, let's see, there it is, now I have it. Now I'm going to have /28 as a summary pointing to null 0. So remember, R1, even though logically appears to be an ABR here, functionally and technically speaking, it is an ASBR because it generates type 5 LSAs. So if we go all the way to R5, if I do show IP route OSPF, I now see that this route here is /28. We remember it used to be /30 here. So now it's /28 and our summary actually did work there. Let's now talk about route filtering in OSPF. Primary filtering that can be done in OSPF is the filtering of inter-area type 3 routes using IP prefix lists and the command set called filter lists. Now, filter lists are going to be referenced on an area configuration in OSPF, and they have to reference a prefix list. So we have to define a prefix list that is either going to permit or deny certain routes. If the prefix list permits the routes, they will be allowed to be advertised in a particular direction. I'll talk about the direction in a second. And if the prefix list denies something, then those routes will be denied. Keep in mind that filter lists will affect only type 3 LSAs. Type 5 or type 7 LSAs are unaffected by the filter lists. So let's analyze this configuration here. So here, and let's say that I had this configured on the router that is an ABR between, let's say, area 10 and area 0 here. So let's say that this is our R1. Now, here I have two configurations, two configuration lines. The first one says area 10 filter list, prefix list PL1, whatever was defined in the prefix list, and it says in direction here. Now, the important thing to understand here is that these prefix lists and the filter lists, the in and out direction, is the exact opposite of what you would, for example, use if you used access lists for traffic filtering. What this here means is filter the routes specified in the prefix list 1 when they are being advertised in to the area 10. So this would be for in direction, not for the out. The routes are not being advertised out into the area 10. They are being injected in to the area 10. So this is going to be filtering the routes in that direction. Now, this second line here, area 10 filter list prefix PL2 out, is for the routes that are attempting to go out of area 10, which means that they are going to be injected into area 0. So this is going to be filtering the routes going out. Now, with this in mind, there is an equivalent setup of this that looks a little bit different. And here it is. Now take a look at this logic here. Here I'm saying area 0 filter list prefix PL2 in, which is basically the same thing that I have done here, given that only areas 0 and 10 exist on this ABR. If there are other areas, then these two are not equivalent. Because with this configuration here, when I say filter the routes as they are being advertised into the area 0. I'm not saying from which area. This applies to all areas that are attempting to inject their prefixes into area 0. This filter here, however, affects only area 10. But if we only have area 0 and area 10 on our routers, these two configurations here are functionally equivalent configurations. Now, there is another way to filter the routes between the areas, and that is to use the summarization. So if you are uncomfortable with prefix lists and you have relatively simple filtering to implement, you can also do something like this. Now, we know that area 10 command, area 10 range command, is going to specify the summary that is then going to be injected into area 0. But if we use this special keyword not advertise at the end of the area range command, what's going to happen? All routes that are covered by this range here are simply not going to be advertised and not going to be injected into a particular area. Now, let's take a look at these examples in action. I'm going to go back to these examples that I configured here, and I already have some routes that are being summarized and they're being sent left and right. So let's see what we can do here in area 45. So I'm going to go to router R4 and I'm going to say show IP route OSPF. Let me see what I have here. Now, what I want to do now is I want to filter some routes as they are going in to the area 45. So the best place to look actually would be on R5. So I'm going to take a look at R5 here, and the routes that I can filter here would be this route and these two routes. And how can I cover them with a single summary? Well, what I could do is I could say, for example, let's filter this route out. I don't want 192.168.134.0 to be advertised in to the area 45. I have to do it on the ABR. So here on R4, I'm going to create, let's say, IP prefix list. I'm going to call it PL1, and I'm going to say deny. And what I want to deny is 192.168.134.0/24 network. And keep in mind that at the end of every prefix list, there is going to be an implicit deny everything. So I need to permit everything else. So this is going to be my prefix list. So I'm going to go now into router OSPF, and I'm going to say area 45 filter list prefix PL1 in. So I want to filter these routes as they are being injected into the area. And I was a little bit too fast, so there we go. Now I can see that this network 192.168.134.0/24 that was in my routing table as the inter-area route is now gone from the output. But these two have already, they have not been covered by that prefix list, so they are being allowed through. But now let me show you how my prefix list is not actually going to affect the external routes. So I'm going to go to area 45, and I'm going to say, I'm going to first remove the prefix. Actually, you know what? I'm going to create a new prefix list. I'm just going to say IP prefix list, and let's call it deny all. So I want to create a prefix list that is simply going to deny all routes. So this is the prefix list that denies everything. And I'm going to go and say router OSPF1. I'm going to remove this prefix list in, and I'm going to add this prefix list here. So if I go to R5 now, and if I do show IP route OSPF, what I'm expecting to see is that all routes are going to disappear from the routing table. So I'm expecting to see all of these gone, but I don't, because this route here, the external route, is unaffected by the filter list command. It cannot be affected because the flooding scope of type 5 LSA is the entire domain. If it exists in area 0, it has to exist in area 45. So how would I filter this? How would I get rid of, for example, this prefix? Well, first of all, we have to figure out which one of the routers is injecting this prefix. So what I could do is I could say show IP OSPF database external, and what I'm looking for here is the advertising router, and I can see it's router 1. So how can I filter these external routes? Well, there are a couple of ways to filter the external routes. The simplest one would be simply don't redistribute the external routes. Now, a less simple one would be, for example, slight mistake. The less simple one would be to use route maps at the redistribution point. So I would say redistribute something or the other, and I would specify the route map, and in the route map I would reference the access list, prefix list, route type, whatever else. But I can also use summarization syntax to prevent the routes from being advertised. And I can do summary address and then specify the summary that I want to create, and instead of advertising it, I can use the not advertise keyword. So this is very, very similar to, for example, this configuration for inter-area routes. So let's take a look at these two. Going back to my terminal here, let's first try some of the inter-area routes in that direction. So I'm going to go to R3 here, and I'm going to look at show IP route OSPF, and what I'm looking for here would be something that comes from R4, and there is one route here from R4, and it's this 192.168.0.0/29, and it's an inter-area route. So that must be here on R4. A summary that I have already configured, and yes, there it is. So here I have area 45 range, where I am actually creating a summary there. So let's modify this. So I'm going to use this now, and I'm going to say not advertise here. So if I go to my R3 now, I will see that this route is now gone. There it was here, and now I no longer have it here in my routing table. So using the summary syntax, I have actually removed this route. I have filtered it out between my routing, between my areas. Let's do the same thing on R1 here, where I have the summary address configured, and this is summarizing type 7 LSAs as they're coming in. So I'm going to do here summary address, and I'm going to say not advertise. So if I go back to R5, if I do show IP OSPF database external, okay, now I can see that the metric there is much larger, and now I can see that it disappeared from the database. Show IP route OSPF, I can see that on R5 I have no OSPF routes. I have effectively filtered them all out. So going back to this slide here, when you're filtering the external routes, as I said, there are multiple ways to do it. Don't redistribute them, the simplest one. Then I can use route maps. I can use the summarization syntax, and the summarization syntax is the only way to filter on the translating ABR or ASBR, depending on how you want to call it, logically or technically, the function it performs. So this is the only way to filter those translated routes, just like we did on our R1. The last example of OSPF filtering is the local routing table filtering. As you know, OSPF has an OSPF database where all the LSAs are kept. The intra-area routes, type 1 and type 2 LSAs, type 3 LSAs for inter-area routes, type 5 with type 4 for the external routes, and type 7s for the external routes in the NSSA area. All the filtering that we examined so far dealt with either filtering type 5 or type 7, or with filtering of type 3 LSAs. But what if we wanted to filter inside an area? Is that possible? Well, the short answer is perhaps. What I mean by perhaps is it is not possible to filter these prefixes as they are advertised between different routers. So if we had, for example, R1 that is connected to R2, And on R1, we had, say, loopback interface that was enabled for OSPF. If this loopback was inserted into the OSPF database, there would be no way for us to selectively filter this when advertising to R2, given that R1 and R2 are in the same area. Now, what we can do though is when this prefix was advertised to R2 and R2 has it in its database, what we could filter is between this database and the routing table of R2. This is the place where we can insert the filter. This is where we can actually perform filtering. So we can filter between the database and the routing table locally on the router, but we cannot selectively filter the LSAs as they are being transmitted between different routers. So this filtering infrastructure, this local filtering infrastructure, is used to filter the internal routes. And it is possible only in the inbound direction. And I put inbound here under the quotes because what we are really talking about here is the filtering between the database and the routing table. And when you are performing the filtering, you have to be thinking that you are implementing filter here. So we can filter as the routes, as the prefixes are arriving from the database to the routing table. We cannot implement any sort of outbound filtering with this infrastructure. And this infrastructure, this filtering of internal routes in OSPF, uses distribute lists under the OSPF process. So we would go under the router OSPF, let's say 1, and then we would here type an appropriate command. I say type an appropriate command because here I'm going to show you a couple of examples, but they are not all compatible with each other. That means that I couldn't configure all of these at the same time. For example, if I configured this example here and I tried to apply, for example, this one, I would get an error message from iOS telling me that this command here has already been configured. So some of them are mutually exclusive, but I'm going to go through these examples and explain what is it that they actually do. So let's take a look at the first one here. Now, what this does here, it is implementing the filter, as I said, between the database and the routing table in the inbound direction, and it's specifying an access list number 1. That means it is going to be using the standard access list to filter the routes. And remember, when we are filtering using the access lists, what we can specify are the networks, but we cannot match the net mask. So with access lists, the net mask filtering, the prefix length is not possible. If we wanted to do that, if we wanted to match specific prefixes, we would use, for example, this syntax here. We would use distribute list prefix PL1 in. These two are roughly equivalent, except that this one here uses an ACL and this one here uses the prefix list. Another example that we can use is, for example, this. It says distribute list 2 in the inbound direction gigabit interface 1. So what this command here is going to do, it is, remember, not going to filter any LSAs. So we are still going to be receiving LSAs. But when the routing table is being calculated, when OSPF calculates the best paths, those prefixes that have an exit interface that would be installed in a routing table with the outgoing interface of gigabit 1, they're going to be sent to the access list 2 for filtering. And we can use pretty much the same syntax with the prefix list. We could say distribute list prefix PL2 in gigabit Ethernet 1. So it's a very, very similar example there. Now, two special cases that I would like to mention here are this gateway filtering and using the extended access lists here. Now, with both extended access lists and the gateway, we can filter the routes based on where the information comes from. But there is a significant difference in how these two operate. So I'm going to first talk about distribute list 100 in. So let's say that we had in our network 3 routers, R1, R2, and R3. And let's say that I was implementing this command on R3. Again, remember, this is between the database and the routing table. So what I'm going to do with distribute list 100 in the source part of the access list, I'm going to specify the router ID, so not the IP address, the router ID of the originator of the LSA. So whatever LSAs that I'm interested in, and in the destination part of the extended access list, I'm going to list the prefix. Again, remember that with access lists, in this context, we cannot filter based on the prefix length. So just basically the network here. So what I'm saying here is, if I have the route, it was originated by a particular router, and it is a particular route, let's say filter it out. Now, let's say that we wanted to filter the routes generated by router ID of R1. So what we would say here on this prefix list that is applied on R3, we would say distribute list 100 in, and then we would say access list 100, say deny host 0001.00000, and then any. That basically means deny any routes coming or that were actually originated by R1. So this is how we can use the extended access list to actually match the origin point, the origin router ID of our route. On the other hand, using the gateway keyword here allows us in a similar scenario on, let's say, R3 here, to filter the routes if they are in their calculated form have this IP address as next hop. So we would say, for example, let's say that this was 192.168.23.0/24, and that this was .2 here. If I wanted to filter all the routes that have this as the next hop on R3 between the database and the routing table, what I would say is, for example, access list, or I would say prefix list PL2, I would say IP prefix list PL2 deny 192.168.23.2/32, which would match this IP address here, and that would mean that all the prefixes that would be installed in the routing table with this as the next hop by OSPF process would actually be denied. And keep in mind that we can also specify interface here or interface here. Even though I have used the interface as an example only here, that doesn't mean that you cannot use the interface to specify this filtering. And last but not the least, we can use route maps. Now, route maps are probably the most flexible filtering form, because there we can use either the access lists or the prefix lists or the route type, the metric type, whatever is that we can match in the route map we can use to actually specify where or what we want to filter. So all this filtering of internal routes is possible only in this pseudo inbound direction. But what about the outbound filtering? Well, tough luck there. You have only per interface all or nothing. The only way to filter the LSAs as they are being advertised to other neighbors is to tell our router that on this interface we don't actually want to advertise any LSAs. And the command to do that under the interface will be OSPF database filter all out. That is simply going to stop advertising any LSAs out of this interface. And the purpose of this command is to make maintenance and changes in the network simpler. Let's say that we had a router that had 2 uplinks, or let's say that it had 1 uplink really, and we wanted to take this router out of service. We wanted to shut it down, for example. And let's say that this router here was providing some service to some other routers on this interface. When we send out this, when you configure this database filter all out, what we are going to be doing, we are going to be causing these routers here to gracefully reroute the traffic over their other uplinks, and once that happens, we can take this router out of service without much impact. So this is kind of a transitory, a temporary command that we can put in our routers to ease the transitions.